Welcome to Wes Explains Best. We're starting surface area and volume today for our geometry students. This is part one of two-part videos, so make sure you stay tuned for both to get a well-rounded informational session on what is surface area and volume of prisms and cylinders. So let's start with prism. What is a prism? A prism is a 3D shape with rectangular sides. So think like a cereal box. Okay, or any sort of packaging like an Amazon package. Those are all prisms. So the important part of understanding what a prism is you need to understand its base. So there's only two bases. I mean, we can technically with a rectangular prism, you could call any the base, but there's only two bases of a prism. You need to identify what is the base. So for example, this is a rectangular base. But we could look at this one. This one has a circular base. We already understand that has a special name. This is a cylinder. And then we could have a triangular base for this problem. So it's really it's like the first step in understanding prisms is you need to identify the base. Then we have these red things, these dots on the corners. We're just talking about the very corner. And those are the vertices. Those are the pokiest part of the box, the Amazon box. These are vertices. So each one is called a vertex. The purple, this is a lateral edge. So any sort of edge running along the side, it's a line. So a vertex was a point, a lateral edge is a line. And then this green one is a special lateral edge called a height. And the reason why I know it's a height is because it's been given that it's 90 degrees. Now these are all important parts of a prism to identify. The lateral faces, here we see this in this kind of pink color. This is a lateral face. Lateral face. So these are rectangular sides, and they are not the bases. Remember, there's only two bases. Now, how do we find the lateral area? So the lateral area would be the sum of all the lateral sides. So if I were to take each one of these sides, so this is, right here I'm working with an oblique prism, which I'll talk about in a second, but if I were to add up all these sides, so here I have blue, in the back I have that green side, then I take this yellow side and I add this up, and then in the front, this is going to cover up a lot, but then I have the red side out in front. If I were to add up all those sides, it would give me the lateral area. So I could just, for lateral area, I could do the sum of the sides. Now, for an oblique prism, it's going to be parallelograms that you're dealing with. So see how it's not a rectangle? Over here, this is a rectangle for this one, 90-degree angles. But for an oblique, you're going to have parallelograms, so you need to calculate the area of the parallelograms. For non-oblique lateral area, you can use this handy formula. It makes it much quicker. So instead of adding up all the sides, you take the perimeter of the base, and you multiply that by the height of the prism. That's a much quicker way to handle it. Essentially with the perimeter, you're adding up all the different widths of the rectangles and then multiplying it by the height all at once. So taking the perimeter, you account for all the rectangles. Even if it's a hexagonal prism, you account for all the rectangles and then you multiply it by the height. So that's a quick way. This is for non-oblique. Okay. Now that's lateral area. Lateral area is useful for any time you're dealing with like packaging. So if you had like a cereal box and you wanted to have some packaging for the sides, and you wanted to know how much material you needed, that's what's useful about lateral area. Okay, so lateral area is just the sides. Surface area is everything. Anything that's exposed to air. That means the top, the bottom, the left, right side. Okay, so if you're thinking about surface area, you're talking about all the cardboard of the Amazon box. So surface area is equal to the lateral area, that's the sides, but now you need to add in the two bases. Now, notice how I use a capital B. This stands for the area of a base. Now, when we're talking about, again, capital B, we're talking about the base of a 3D shape. So this is a base of 3D shape. This is different than like a base of a triangle. So if we had a triangle here, Okay, and then we have a height. Oops, let me get this off a second. Then we have a height. This would be the base in relation to the height. Now, the base, this is a 2D shape we're talking about here, so the base is just this small little line. It's not the area. Okay, this is talking about the area of a base. And we need to multiply it by 2 for this formula because there are 2 bases. So that's important to know. In short, we could combine the 2 formulas that we had for non-oblique prisms, and we could say the perimeter of the base, and I'll write this, perimeter of the base times the height plus 2 times the area of the base. And that would be our surface area formula. Now, oblique prisms we talked about a little bit, but it's essentially just a prism just kind of slanted. So instead of rectangles, for the sides we have 2 parallelograms. So in yellow here, I'm going to kind of draw this. That's a parallelogram. This would be a rectangle still, and you'd add that. But we have not just rectangles, we have parallelograms for sides. So that's just a special type of prism. Be on the lookout for that. Now, a cylinder is very similar to a prism, but instead of like a triangle or an octagon or a hexagon or I already said triangle, or a square, it's a circle. So it's going to be a little bit different. Our formula is going to be slightly different. We can at least be a little bit more specific to a circle. So we have our parts of the cylinder first we can identify. Well, let's say that it is a prism with that's supposed to be a W, by the way, a circular base. Okay, so if it's a circular base, we have some important parts. This is the radius, and then the other important part is the height. Think about soup cans. That's like probably the easiest thing to visualize when you're talking about cylinders is a soup can. So a soup can has that packaging on the outside, the little label that you can rip off, and once you rip it off, you can lay it flat. Now think, what shape does it become? If you rip off that soup label and you label it, put it flat on your counter, what does it look like? It looks like, hopefully you guys can visualize this, it looks like a rectangle. Oops, I don't know what happened to my rectangle. Disappeared. Call me Houdini. Okay, so there's my rectangle. So I peeled it off. So this green line corresponds to the height. So there's my soup can, and there is my height of my soup can. Now, what is this length then of this rectangle? What would that length be? Question mark. Okay. Now, if I were to roll it up again, what does it become? Let's try to visualize this. If I roll it up again, it becomes the, can you think of it? It becomes the circumference. So it becomes the circumference. So now we can come up with a formula for lateral area. Now, we're talking about the bases for the lateral area. So now we can just write lateral area is equal to, well, we know it's the circumference because it's just a rectangle, based length times width. But now we know that the width, or whatever you want to call it, length, let's call the length the height. Now we know that's h. It was h before, and now we know that the width is the circumference. So now I have my lateral area formula. The circumference times the height. Okay, let's use more specific terminology. I'm going to write 2 pi r. That's the same thing as circumference, and then times the height. That is equal to my lateral area. There's my first formula. Now I'm moving on to surface area. Well, guess what I need to include with my surface area? Surface area, I need to include the 2 bases. The formula stays the same. Notice how the formula stayed the same as up here. And notice how I'm still using the perimeter. The circumference is just another way of saying the perimeter of a circle. So essentially, all prisms can be found by taking the prism, or the perimeter of the prism, of the prism's base, times the height. That's the lateral, and then you add the 2 bases, and the surface area is essentially the same formula. So don't try to memorize formulas, try to understand the ideas behind the formulas. We already know lateral area. Lateral area is 2 pi r times the height, but now we need to factor in the 2 bases. Well, we know one of the bases of a triangle, a base is going to be equal to pi r squared. That's the area of a circle. Pi r squared equals the area. So now we just put pi r squared here, and that should give us our formula for all of it. So we can write this as 2 pi r h plus 2 pi r squared. And that is our surface area formula for a cylinder. An oblique cylinder is very similar. We're not really going to go into surface area that much, but it is important to know that this is what an oblique cylinder looks like, and this is the height. This is going to be useful for when we're calculating the volumes of oblique cylinders. You don't see them too often, but we will prepare you. Stay tuned for the next video when we talk about the following examples of how we apply the surface area formulas. See you next time.